Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help ISU actuary. Here's a problem for today for exam LTAM. That stands for Long-Term Actuarial Models. Bernard, 80, who is healthy, wants to purchase a critical illness insurance policy. The insurer uses the following model to value the benefits. There are three states: healthy, state 0, critically ill, state 1, and state of being dead, which is state 2. The insurance pays the following benefits: $50,000 at the year end if Bernard is critically ill at that time, having been healthy at the start of the year. $50,000 at the year end if Bernard dies during the year, having been critically ill at the start of the year. $100,000 at the year end if Bernard dies during the year, having been healthy at the start of the year. You are given that the probability of transition from state 0 to state 0 is the same at age 80 and 81, and it's 0.90, and the probability of transition from state 0 to state 1 is the same at age 80 and 81, and it's 0.04. Probability of transition from state 1 to state 2 within a year from age 81 is 1. Interest rate is 5%. Calculate the expected present value of the benefits payable during the first 2 years. And here's the solution. The expected present value of the benefits payable during the first 2 years is 50,000 times the probability of transitioning from state 0 to state 1 within the year at age 80, divided by 1.05 to calculate the present value, because of the payment being at the end of the first year, plus 50,000 times the probability of transitioning, of staying in state 0 in the first year, and then transitioning from state 0 to state 1 the second year, and divided by 1.05 squared to calculate the present value from time 2, plus 50,000 times probability of transitioning from state 0 to state 1 at age 80, and then transitioning from state 1 to state 2 at age 81. Unfortunately, I had 80 there. That was a typo. I corrected it to 81. And then 100,000 times probability of transitioning from state 0 to state 2 at age 80, divided by 1.05 to adjust for the to calculate the present value at time 0 of the payment at time 1, or 1 year after age 80, plus 100,000 times probability of transitioning from state 0 to state 0, so staying in state 0, times the probability of transitioning within a year at age 81 from state 0 to state 2. And this is the death benefit of 100,000. And that's divided by 1.05 squared to calculate the present value. And now we just plug in all these probabilities. Note that the probability of transitioning from state 0 to state 2 is not directly given in the problem, but it's equal to 1 minus the probability of transitioning from state 0 to state 0 minus the probability of transitioning from state 0 to state 1. So 1 minus 0.9 minus 0.04. Note that also the probability of transitioning from state 0 to state 0 or state 0 to state 1 is the same at both ages. So otherwise we plug in all these probabilities, do the calculation, and we end up with approximately 15,963.72, which is answer A. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.